All right, let's get through a couple more of the fundamentals, the things that you're probably just going to click the button in your homework because it'll be multiple choice. So you can get credit for it. And then it's going to pop back up, and it's going to be highly important that you actually understand that stuff to solve some problems, especially when you got to take a midterm, right? But this next part, it's not so important quite yet. Quite yet. It's going to become quite important once we start graphing. So we got to talk about this again. Last one, we talked about the domain. The domain. Talking about what angles are we allowed to plug in. And then we're going to talk about the range as to what values we pop out. So just to make sure we're all in the same spot. Sine of an angle is equal to a ratio. This would be our values or our range. We want to know what are all the ranges we could possibly have. And then we can maybe ask, well, what values of theta can we pop in? So, for example, I could pop in sine of pi over 6. Pi over 6 is in the domain of the angles. It could be any angle you want to. And that's going to pop out an answer of 1/2. That's the ratio of a triangle, saying if the angle is pi over 6, the opposite is 1, and the ratio is 2. So we're asking, what type of triangles could we make out of this? And I know it starts off and it doesn't seem like there's a lot of triangles, but there are. So let me just give you one. Let me say, I'm going to give you something that's incorrect to see if maybe we can catch this. Let's say sine of an angle is equal to 2, no, let me use a different number. Let's make it 3 over 2. And let's make a triangle, huh? Why is that so? Let's make a triangle. So we're saying, all right, so we have some sort of angle on this triangle. This is our opposite, right? SOHCAHTOA. That's our hypotenuse. So we're claiming the shorter side is longer than the longest side. Do you think the hypotenuse can be 2 and then the other side is 3? That's impossible. The hypotenuse is always the longest. This is impossible. You can never have the numerator be larger than the denominator. That's impossible. So when we start going through the range of these, we're actually going to find out that sine and cosine, I didn't put negatives on there, are always between -1 and 1. They're never larger than that. For right now, just go, okay. Once we start to graph it in 2.4, you're going to be like, oh, yeah, okay, that makes sense now. I see. Or maybe it doesn't make sense, but you see it in the graph. Now, let's move on to tangent of an angle, which is our opposite over our adjacent. So let's make a triangle. Let me call this, it's not to scale, 15,000 over 1. So wouldn't this be 15,000 over 1? Oh, maybe I wrote it wrong. Sorry, not to scale. Maybe I just wrote it wrong. Maybe that one's 1 and this is 20,000. So we could get 1 over 20,000. Oh man, so it could be super small or it could be super big. And because we're not dealing with the hypotenuse, we're only dealing with the opposite and the adjacent. We can actually get any ratio you want. I mean, it could have been, you know what I mean? Not to scale again. I'm going to call this 1 and I'm going to call this, just tell me when to stop writing zeros. All right, so it's 1 trillion. Not to scale, of course. Not to scale. So it's saying your tangents, you can get any freaking ratio you want out of it. -infinity to infinity. Cotangent, same thing. We're just flipping them over. Now here's the weird, and I'm not even going to get into too much explanations yet. I think it's going to be a lot simpler for us to see this once we get into 2.4 and we start to graph. So for right now, that just is. If you get a multiple choice problem, just click on the dang button and go, all right, there it is. There it is. That's what we're doing. Okay. Let's do one last thing, and this is going to be what we call the period of trig functions. Once again, this section is really just geared up to get us ready, or this video essentially, is just setting us up to get ready to graph. So don't stress too much. You're going to have to answer your question. So we're going to say, I'm going to write this down. Did you know that when you spin around in a circle, you end up back where you started. The unit circle. Go around in a circle. It takes 360 degrees to spin around, doesn't it? Or, oh, I'm sorry. I wrote that wrong. Whoa. 0 and 2 pi, right? Those are the same things. Please don't think that degrees and radians are something different. I mean, they're different, just like Fahrenheit and Celsius are different. But they're still a measure of the temperature. Just two different ways of writing it. You know, like inches and centimeters? They still get you a length. It's just two different ways of finding them. Same way. So here comes the game for the period. The period means how long. So we're asking, how long until the function repeats? How long does it take to go around in an effing circle? You know what I mean? Can you see how long it takes for it to repeat? So this is going to be terrible. We're going to say sine of theta is equal to sine of theta plus 2 pi k, where k is an integer. And you're like, what are you writing there, dude? I see Greek. I see more Greek. I see k's. Where's the numbers besides the 2? I could write this differently. Does this help? Probably not. But what this is saying it takes 2 pi to spin back around in a circle and then back where you started again. Because in trig, it doesn't really, trig functions don't care how many times you spin around in a circle. They only care where you end up. So I want to look at an angle, pi over 6. And then I want to spin around in a circle. I want to go all the way around in a circle. And I want to add 2 pi to that. So we have 11 pi over 6. So what's coterminal to it is adding 2 pi, which would be 13 pi over 6. For sine, it's saying it doesn't really matter. As long as you spin around in the circle, you still terminate in the same spot. As long as there's coterminal angles, you're still going to get the same gosh darn answer out of it. So what we did is I just wrote in this. Sine of pi over 6 is the exact same thing as sine of pi over 6 plus 2 pi. I just chose my k to be 1. K is an integer, or how many times you spin around in a circle. So we got that is equal to sine of 13 pi over 6. They're the same thing. That is a giant game, though. Oh my goodness, for solving, that's everything. But we'll see that game later. So it's also true for cosine. And I'm just going to write it with the radians. It's also true for cosecant. Sine flipped over. That's also true. Saying if you spin around in a circle, you end up back where you started. It's also true for secant. But then we have 2 oddballs. 2 oddballs. So it takes 2 pi to repeat for the first 4 trigonometric functions. But then we have... sorry about that. I'm not stopping. Continue on. Tangent and cotangent behave a little differently. But just do your... It only takes pi for it to repeat. They only take pi to repeat. Or, I'm sorry. Did I say pi? I meant 180 degrees. For right now, don't stress about that. Just have it down so you can answer your homework problems. It will pop up later while this will be important. But there's the period of your trig functions. In future videos, once we start to mess around with these things, once we start to do more exact values, I think you're going to see that these are not, that they will be useful, but in a different way. It might be stuck in your head. So I will see you in the next one.